Alright everyone, so let's get started with the simplification of expressions consisting of algebraic fractions. This first expression we're looking at here deals with the addition of two algebraic expressions, where if we look carefully, we can see in these particular rational expressions, we have terms where the denominators are different. When we're dealing with algebraic fractions, one of the things that we need to always be able to recall to memory is how we handle the operations on fractions. So once you are familiar with the processes of doing things like addition, subtraction, multiplication, and division with just plain fractions, you'll be able to extend it into algebraic fractions, because the only thing that's actually changing here is now you're dealing with algebraic terms involved with your fractions. If you have an example of an algebraic expression involving addition like this one, it's always important to take a look at whether or not your denominators are the same, because just like in dealing with fractions, you would want to know whether or not you can perform the addition on the fractions just as they are. And we know that usually if the denominators are the same, all we actually have to do is add our numerators together. However, we can see that it's not the case. This particular expression contains two rational expressions where the denominators are different. We have 5 and we have 3. So in a case like this, we actually go about solving the problem by finding the LCM. Once we're able to identify the LCM, the process of simplification follows quite similarly to what we would have done with fractions. So let's talk about finding the LCM, and in this case we're dealing with two numerical denominators. So our LCM is as simple as finding that common multiple between 5 and 3, which is 15. So our next objective here is to convert these two fractions into their respective equivalent fractions out of a denominator of 15. From here, the procedure is usually find how many times our previous denominator goes into our current denominator, take that factor, multiply it by our numerator. So what we'll do here, 5 into 15 will give us 3, and we're going to multiply our numerator 2x by 3. So when I multiply 2x by 3, I get 6x, and then I'm going to repeat the process, but this time I'm going to ask myself how many times is 3 going to 15, and I'll get 5. And multiplying my numerator x by 5 will give me 5x. Now that I've converted both these fractions to their equivalent fractions, all that's left to do is find the sum of my new numerators, because now these numerators are the numerators for the fractions out of 15. So my denominator here, they would be the same. And when I find the sum of these numerators, I'm going to simply get 11x. So I need to remember that here I'm adding two algebraic terms containing x, and I must always remember that when I find the sum of these two terms, I must also contain my variable. Alright, some common mistakes, things that you see happen pretty frequently. They find the sum of 6x and 5x, and for some reason you end up getting 11x squared, or sometimes you see things where they leave off the variable completely. Alright, so just want to encourage you to pay close attention to your process when you're performing the addition on algebraic terms. Remember, you add together only like terms, and definitely pay attention to your variables. When you are adding the same variable together, you are not to raise any powers, you're not performing a multiplication. So just some things to look out for. But this is a procedure we use when we want to perform the addition of algebraic fractions, and in this case the process was quite simple to do because our numerators here were both numerical. Now, it doesn't mean that the numerators cannot ever come as two algebraic expressions, and in fact, we're going to take a look at an expression in a short bit where both the denominators are different,